All right, we'll begin. I believe my screen is shared. Well, happy Monday, everybody. It is now second week, and I guess we're gonna be online for all of January. So that's a little well, for me, disappointing. I don't know how everybody else feels about it. So I came up with I had this idea, and I did this last year, and it was I think it was good. I had fun. So one thing that we miss out on when we switch when we're all online is you miss like finding out who your classmates are, right? And so maybe some of you already know some of your classmates, but I have a good chance that a lot of you don't know who some of your classmates are. And that is part of why I always kind of ask, like, oh, turn on your camera so at least you can like see some of each other's faces and be like, oh, I recognize your face. And then when you meet them in person, you're always surprised, like, oh, you're like way taller than I thought you were or something. But anyway, I was gonna do something. So this was inspired by UCLA's Dinner with Strangers thing. Have you guys ever participated in that Dinner with 12 Strangers? Okay, well, anyway, UCLA's, I don't know, I think it's the Alumni Association. They do Dinner with Strangers, and it's a good time. And if it weren't for the pandemic, I would highly recommend it. And well, anyway, I think they're like doing online Dinner with Strangers, and I don't know, maybe this year it's back in person. I don't know. But anyway, I thought we could do some online dinner with classmates. And so I'll have a sign up sheet. It's completely optional. If you're like, oh my goodness, I hate talking to people, don't, this is not the event for you, okay? But basically, I probably dinner something, maybe I'll eat dinner somewhere around 7 o'clock or something. And so so just if you sign up for it, you'll just log in at, we'll pick a designated time, probably like 7 o'clock. We'll log in, and then we'll chat, and you could eat your dinner in front of your computer. You don't have to. Maybe you can just chat and hang out, and we'll just hang out for an hour or so, and that will be it. And that will be just a chance for you to meet some of your classmates. I'll have a sign-up sheet, and I'll probably put 8 people in a group or something like that. So if that sounds interesting to you, you can sign up. And if that sounds like the worst thing imaginable, then don't sign up, and that's okay. All right. There's no like extra credit or anything. It's just purely if you want to meet who some of your classmates are. Maybe that's a chance to do so, just because, well, we're online. So anyway, okay. What are we talking about today? Programming basics, conditions, and loops. And we are in R. I always have to like switch my brains because immediately before this, I teach a class in Python. So now we are doing R. And so here we got, okay, operators that produce logical values. This is very important, just because when we do conditionals, it's all based on if some condition, right? If true, if false, and basically the conditional statements only operate when that thing is true, when the condition is true, right? So we have these logical operators, and these operators, the or, the and, the not, these will all kind of coerce values to logical, even if they're not logical types. So remember, basically, if you got 0, it becomes false, but pretty much any other numeric value is going to become true. So you do, you got X or Y, X and Y, not X, and then you have the exclusive or, which is basically true if only one is true and the other one is false. Okay, these are all vectorized, and so if X is a vector or Y is a vector, they're going to do element-wise comparison along with recycling. And so, and then on the other hand, we have the non-vector or and the non-vectorized Y, okay, which is the double or and the double and. And these things return only one value. So if X is a vector a length greater than 1, or y is a vector length greater than 1, it's only going to use the first value. You shouldn't do this. Okay, you shouldn't give it a vector length greater than 1 for x or y if you're going to use the non-vector. But in case you do, if you accidentally do, it will only do this, the non-vector thing. Okay, so so it reads left to right, so it's only going to look at the first element, and it's only going to do that. And this is useful really when you're putting it inside an if statement. An if statement only accepts one logical value, and so this is really the only time where you are going to be using this. Okay, so here is, I've got this vector true, true, false, 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 true, false, true. And so here with it being vectorized, okay, the ors give me trues for everything except where it's false, false. And the and gives you false everywhere except for it's true, true. Whereas the non-vector or and the non-vector and only looks at the first element. So the non-vector or is true, the non-vector and is false. What do we get when we do true or NA, or true and NA, or false or NA and false and NA? What do you guys think? So true or NA. So imagine what's inside NA. NA could be true or false. NA could be true or false. So with true or NA, whatever it is, it's going to be true, right? Whereas true and NA, yeah, you guys are putting in the your answers in the chat here. True and NA, well, it depends whether this is true or false. Okay, so whether this is true or false, we don't know. Okay, and similar logic. So whatever NA is, true or NA is going to evaluate to true. Okay, whatever NA is will determine whether this thing evaluates to true or false. So it depends on our missing value. Same thing here, false or NA. It could be false if NA is false, if this missing value is false, or it could be true if this missing value ends up being true. Whereas the false and NA, no matter what NA is, whatever this missing value turns out to be, the answer is going to be false. So, so it evaluates, right? So just because you have a missing value doesn't mean you're going to get a missing statement at the end. Okay, so here I've got a longer vector, and with the exclusive or is only true if one thing is true and the other thing is false. So true false evaluates to true, true true evaluates false, false false evaluates false, but false true evaluates true. And anytime you have missing values, NAs, everything's going to be NA because you need to have exactly one true and exactly one false. Okay, we've got any, we've got all. Any is kind of like the generalization of or, and all is the generalization for and. And so the default value for any is if any of the values are true. Okay, so here everything is true. So are any of the values true? Yes. Are all of the values true? Yes. Okay, here I've got true, true, false. Are any of the values true? Yes. Are all of the values true? No. Okay, false, false, false. Are any of the values true? Nope. Are all of the values true? Nope. We have false and false. Is that okay here? I've combined the response to any and all into a single output here. I think this showed up in your homework, but we'll post it here as well. So if we were to put a logical zero length vector like logical zero or null, if we add this to a vector of logical values, right, it should not affect the result applied to V, right? So V evaluates to true, and we were to insert null or logical zero into there, then it should just remain what it is. It shouldn't change the result. So that is, if I say any logical zero along with V will return the same thing as V, any logical zero V, or all logical V will return the same thing as V. So what would any logical zero return? And what does all logical zero return? Oh, there's a question in the chat. Are any and all only for logicals? Yes, yes, they are only for logicals. Just like ors and ands are only for logicals, or these Boolean values, any and all are also apply only to logicals. Okay. What does any logical zero return? What does all logical zero return? And while you guys are thinking about this, let me give you your first view quiz answer. Today's first view quiz answer is the letter A. A as in apple, or A as in aardvark. Okay, let's take a look. So any logical zero is going to return false. How's that? Okay, so here x is going to be our logical zero. And so if I were to include x into u, so here I've got any u, true, true, true will remain, evaluates to true. And if I put in logical zero here, and I put in true, 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 and now a logical zero, that will remain true, right? So even though logical zero evaluates to false, are any of these things true? Yes, that's going to be true. Okay. Whereas true, true, false, this will still evaluate to true. And notice if any logical zero evaluated to true, if any logical zero evaluated to true, this answer would change, right? So if I got false, 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 any on the original vector will evaluate to false. But if this x, the logical zero evaluated to true, any on x and w would change from false to true. If x evaluated to true, if the logical zero evaluated to true, this thing would change. And we don't want that. So any on x needs to evaluate to false. I hope that makes sense. Okay, and then the flip side for logical zero, if you do all on logical zero, it's going to evaluate to true, right? And the key distinction here is going to apply here. So if all on the logical zero evaluated to false, this thing where u is true, 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 this would, this evaluates to true, but if all on the logical zero evaluated to false, then this statement would change. All on the x and u, we would have a false in here that would evaluate to false, okay? Whereas all of these other statements, these all don't change. They all get evaluated to false, and it doesn't matter if this evaluates to true or not. Are all of them true? The answer is going to be no here. We got comparison operators, so we can do any kind of, we can put values in here and we can test for equality. We can test for inequality. We can test for less than or greater than, less than or equal to, greater than or equal to. And you can also test for inclusion. Is x an element that is contained inside y? All of these are vectorized. All of them perform recycling in that, you know, if you give it a vector of length 2 and a vector of length 6, it's going to recycle those values. So for character strings, you can actually do comparisons as well. And it's basically comparisons based on alphabetical order, where basically all of the symbols are evaluated as less than any of the numbers, okay? And the numbers are evaluated as less than the letters, and the letters, you know, A comes before B, comes before C, and the lowercase version comes before the capital version. All right, we have a question, however, before we go on. It says, for the logical zero example, how can any x yield false, but all x yield true? How can all be true if any is false to be? Okay, so yeah, this is the premise between how any x becomes false and all x becomes true when we're talking about x being a logical zero. The idea being, with logical zero, if we were to insert logical zero, basically a null value, it should not have any effect on how this thing gets evaluated. All right, and so if any x evaluated to say true here, then in inserting the logical 0 into this thing would result in a different result. Okay, and we don't want that to happen. So that's why it evaluates this way. Okay, and then with the same logic applies here. It might take a few minutes and you might have to review this, but just imagine inserting this logical 0 into this vector, okay, which technically doesn't affect the vector, but imagine if this had evaluated to say false here, what would the result of all u be versus the result of all x and u be? And if this evaluated to false, then this would end up evaluating to false, which violates what we are set out to do, in that the logical 0 should not affect the evaluation of this vector. You know, if it's easier to just accept it as like, this is just what it is, I can also just say this is what it is, and you just have to kind of understand it that way. But I think if you study these examples with some time, I think it will make sense, and I hope it makes sense. There is reasoning behind it, but we can also just say, well, you know, this is also just how it is. But there is reasoning behind it. Okay, so the default value of any is going to be false unless one of the values are true, then it becomes true. And the default value of all is true unless one of the values are false. That's just how it is. But again, there is a logic behind it. And hopefully it's explained in this piece right here, and this piece right here, and perhaps maybe on this slide. Okay, but going back, so with characters, okay, with comparison operators, we can compare strings. And so if we say, is 10 less than 2? Of course, that's false. 10 is not less than 2. Okay. However, character 10, character 10, is that less than character 2? This is true, okay, because it's using alphabetical order. So it's basically alphabetizing it. And sometimes, I don't know if you're if the files on your laptop do this, but sometimes you'll have a file with like you know, you have like picture 1, picture 2, picture 3, and then picture 10. And because it's doing alphabetical order, things with a 1 come before things with a 2. And so 1 and 10 come before 2, and 3, and so on and so forth. Okay, so because it's this is just how it goes. Is this related to ASCII? I mean, ASCII is just the way we have is just how we take the values from the keyboard and input them into the computer. And it was kind of a standard that was set. And basically it's the set of basically these symbols that we can have. But this is just a side effect of alphabetizing based on characters, and not the actual meaning. So this just sees the 1. It's kind of just like the word, you know, apple. You know, A's come before B words, right? Apples come before bears and things like that, and something like that. Okay, can I explain why 9 is greater than 0? It's just the alphabetical order applied to numbers, right? It's a little bit strange, but it just goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, up through Z. Okay, and it's in alphabetical order. And there's technically an alphabetical order for the symbols, and this doesn't make any real logical sense. It's just this is the order that was chosen. Okay, why are the alphabet letters in that order? That's just the order that was chosen. Okay, there's no reason why G needs to come before M, but it does. Okay, and as far as these symbols, there's no reason why $sign should come before question mark, but it does. This was just the arbitrary order that was selected, and this is it. For something like symbols, you probably shouldn't be alphabetizing based on symbols, but you know, sometimes it happens, and that's just what That's just what it is. Okay. Okay. Sorry. But yeah, why is the alphabet in its order? And I don't know if anybody knows. Okay. It just is. It just is. There's you can study the etymology of how we got these characters from, different things. Right. And then, we imported the numbers. Okay. Is functions. Okay. Is anything that starts with is will return a logical value, right? Is NA, is null, is atomic, is logical, and it's going to just be return a true or false value. Okay, I got to speed up. I already gave you one view quiz answer, right? Okay, let's go ahead and give you your second one. Second one today is the letter E. E as an elephant. E as an elephant. E as an elephant. Okay. All right, so we do conditional statements using the if, right? The if, you have some condition, if condition, and if that condition is true, it's going to evaluate the associated block, and if it's false, it's not. Now, the condition inside here has to be a length 1 logical vector, all right? It cannot be true, true, false, or true, false, true, false. It has to be length 1, and if it's longer than length 1, it's only going to look at the first element, right? So if one element only, right? And it cannot be NA, it cannot be missing, right? If, and now it's like, oh, I don't know if it's true or false, right? If if the person is over age 18, let them buy a gun. Okay, that could be a conditional statement, right? And then if you come in and the person says, well, I don't want to tell you my age, all right, we don't know what to do. Okay, so so it's length 1 logical vector, and it cannot be a missing value, right? If it's missing, you got to just say, well, we can't make a decision, right? So conditions of length greater than 1 are accepted with a warning, but only the first element is used. Anything else that gets put in there is going to be coerced to logical, all right? If you put in a missing value into this, you're going to get this error, missing value or true, false needed. This is a very common error, and this happens when you put in an NA here. If this, whatever this thing is, evaluates to NA, you're going to get this error, right? If for whatever reason the condition is length 0, you get an error. Argument is a length 0. Okay. What if my condition is a range? Say I only want numbers between 2 and 4. Is that still allowed? Okay, so you have to you can have a condition that says, is the number between 2 and 4? Is the number between 2 and 4? That's going to be answered with a single yes or no answer. So that's fine. The question has to be answered with a single true or false value. And this condition can be as complicated as you want it to be, right? Is this number a prime number? Well, how do we know it's a prime? Well, is it divisible by itself or and 1 only evenly? And it's like, okay, well, then now there's all kinds of stuff. There's a way to check for that. And then, so that condition can be as complicated as you want it to be, but the condition itself has to be true or false. Okay, and then you group the expressions that are related for when the statement is true. Okay, actually, this gun buying example was a bad example because if somebody's not going to tell you their age, you're just going to say, well, you can't buy a gun. Okay, so that one would actually just be if missing, the answer is going to be no. But it's kind of just like, but something else would be where it's kind of just like you're in a bind where if it's true, you need to do something, and if it's false, you must not do the thing, because basically making a decision one way or another is determine something, right? It's kind of like if if you have a particular disease, take this medication, but if you don't, you definitely should not take the medication, right? And then so if the condition, whether or not the person has a disease or not, is unknown, then that's a problem. You got to do more tests to really figure out whether the person actually has a need for the medication or not, because you don't want to you have to be sure about the default action that you're going to take. Okay, so here we've got a few possibilities, right? X is this vector, 1 and 3 is 1 in X, that's going to evaluate to true. If 1 is in the vector X, print hello. This evaluates to true, so we print hello. Okay, here I've got X is the vector 1, 3, and I say is X greater than or equal to 2. Okay, so X greater than or equal to 2 returns a vector. False for 1, true for 3. And if I put that into here, if X is greater than 2, greater than or equal to 2, now we're putting in a vector of length 2. It's going to see only the first value, the false, so it's not going to print this statement. Okay, and it gives us a warning. It says the condition X greater than or equal to 2 has a length greater than 1. Indeed, it has a length of 2, and only the first element is used, so it's only using the false, and so it doesn't print that. Just the opposite, okay? X less than or equal to 2, again, it's the vector has a length greater than 1, so it uses the first element, it evaluates to true, so it does carry out the code block here, and it prints out hello again. It outputs hello again, but it gives us this warning that says you're giving me a logical vector, and that has more than one element. So I'm only going to use the first element. I think this is a common mistake beginner programmers make, all right? And even advanced programmers, we make these mistakes too, in that we sometimes put in something here that could end up being having a length longer than 1. So what's a better way to do it? Okay, well, we can take this statement, X greater than or equal to 2, and we throw it inside any, right? So any now will take a vector of logical values and then just return one value of true or false, right? Are any of the values true? Are any of the elements in X greater than 2? Yes, and therefore it's going to print out the statement, okay? At least one of the values in X is greater than 2. Okay. If here X is the vector 1, 2, 3, and we can say is the fifth element of X greater than or equal to 2. All right, so what happens? X, the fifth element of X, what is that? It's missing, right? So if you try to subset a vector and you're subsetting a value outside of its range, it's so if we say what's the fifth value in X, we're going to get a missing value. So all of our lectures build off of previous content. So here we're going to get a missing value, and then we say is missing greater than or equal to 2. That's going to be NA. This condition evaluates to NA, and so we get this error. Error in if X greater than or equal to 2. It says missing value where true, false is needed, right? And so a lot of times when you're first getting started and you encounter these error messages, and it's just like, oh, I don't even know how to understand or interpret this. There's actually a lot of good information in these error messages. So when you encounter this error message, missing value where true, false needed, you go, oh, and you see this if statement, you know exactly which line it is, and you can say, okay, well, I have a missing value here. And really the only thing that's a variable here is this. And you can say, okay, well, somehow this thing is ending up as a missing value, is ending up NA. And you can go through and you can try to figure out why NA. Yeah, so if NA always gives an error, if NA always gives an error, you will always get this thing, missing value where true, false needed. If requires either true or false, and that's it. If you try to do something like this, okay, so here X is 1, 2, 3, and I'm asking which value in X is equal to 4, all right? Well, none of the values in X are equal to 4, so this gives me integer 0, right? So if I say, is the value that is equal to 4, is it the fourth element? Is the fourth element the one where the which statement turns out to be true, okay? Well, what does this evaluate to, right? I'm doing integer 0 equals 4. What is that going to give us? Integer 0 equals 4. That will give us logical 0, right? All right, so here I've got this is 1 through 3. Which x is 4? That's integer 0, and I can do is that equal to 4? So integer 0 equal to 4 is going to give me logical 0, right? So integer 0 equal to 4 gives me logical 0. And then so if I try to put this inside here, right? If logical 0, whatever it is, that's going to give me this error. Argument is of length 0. That's what I'm getting. So if you got an if null, right? So if NA always gives you error where missing value where true false needed, and if you do if null, you get argument is a length 0. So these are probably your two most common statements, error statements when you're running with using if statements. Okay, and these again, when you familiarize yourself with the error statements and what causes the error statements, it will help you figure out what you're doing wrong. Okay, you can have nested conditionals, so you can kind of have the if not, otherwise do this. You can have an else if and an else. So here I can say if x is less than 0, it's negative. Else if x is greater than 0, it's positive. Else is 0, right? The else statement only runs if the previously linked if statement is false, okay? And it's important that you put the else on this exact same line as the closing brace, okay? Exact same line as the closing brace. So here x is 3, this is false, so it skips that, then it evaluates this. This is true, so it's going to print out positive. For 0, this is false, so it skips this. This is false, so it skips this. So it must be this, and indeed it prints out 0. If you do something like this statement will never get evaluated, okay? Mathematically, right? So I got x is 3. If x is greater than 0, print positive. Well, this is true, so it's going to print positive, and none of these things will ever get triggered because the else, it only is going to evaluate the else if this thing is false. And because this thing is true, it's going to run this line of code and just be done. So this statement, else if x is greater than 1, this will never run because there's no situation where this statement is false, but this statement is true. So this line of code will never be executed because it can only be executed in the combination that this is false, but this is true. And there's no that would be a null set there. If is not vectorized, but if else is vectorized. So sometimes you want to like check a whole bunch of stuff, and an if statement can only do one at a time. So sometimes you can run it when you use an if else. Okay, so if else is basically equal to this, right? If x is equal to 5, then set n to yes, otherwise set n to no. And you can reduce this to say if else x equal to 5, this is the result if the condition is true. This is the result if the condition is false. And this is vectorized, and we can apply it to here. So let me just show you, I guess we'll show you an example versus the, say, loop, okay? So loops, we've got 4 loops. This is the simplest loop, and you just create a vector, and you get, for x and some vector, and here, we frequently just use integer vectors, but you're not limited to integer vectors. It can do any kind of vector, including lists, and it would just go through every element in whatever vector you provided. So here we're going to say for x and the integer vector 1 through 10, cat or output to the screen, x squared. And so it's going to just give us all of the squares from 1 to 100. Here, my vector is going to be this list, which with the integers 1 through 3, the letters A through G, logical values true, false. And so here I'm going to say for each element in this list, in this vector, print out the length of y. So it goes through the first element. The first element has a length of 3. The second element has a length of 7. The third element has a length of 2. So it prints out 3, 7, and 2. So you can iterate over any kind of thing, and it's just going to go through each element. So again, in this case, we have a train of 3 cars. And when it goes through each element, it actually looks at the contents of the train. It's not going to just be, the train. It's not going to print out length 1, length 1, length 1, saying it's a train, train of 1 element or something. There's a few here. There's some built-in data sets, and state names has the list of all 50 states. And so we can have the first 5 states, Alabama, Alaska, Arizona, Arkansas, California. And we can say for each element in this vector, okay, cat, the name of the state, along with the word has, the number of characters in that name, that value, and cat, this other thing, has letters in its name. So we're going to say Alabama has 7 letters, and Arkansas has 8, and California has 10 letters in its name. So again, we're iterating over just different vectors. When you store the results from a vector, it is recommended that you create an empty object where you're going to store your elements. Okay, so here I've got 10 to the 7. 10 to the 7 is what? 100 million or 10 million? 10 million things. And we're going to say I'm creating a results vector with length 10 million, and we're going to store x squared into each of these things. And so we're going to say for x, and sequence along creates a vector 1 through 10 million going along this thing. And system time is basically just to measure how long it takes our computer to do these calculations. Okay, and this is the good method. You take the vector and you assign it into whatever position it needs to go. Okay, this is not as good. Here, I start off with a 0 length vector, or not 0 length, a vector of length 1 with the element 0. And I do the same kind of thing for x and 1 through 10 million, store x squared in there. It takes a little bit longer. Not that much longer, but a little bit longer, maybe 4 times longer, okay? And the reason why is it has to resize the vector. First it's length 1, then it's length 2, then it's length 3, length 4, and it has to resize the vector every single time. So it takes a little bit longer. Okay, this one is the worst, okay? And that is you create an empty vector, and then you're going to extend it, okay? You're going to copy the entire vector and append something new to it each time and store it back into the results. I've got take the current results, append this, and store it back into results. This takes the longest time. Here I'm only doing 100,000, so this is 1/100th of the work, but it takes the longest at taking 13 seconds to evaluate. Now, for small things, like if you only have 100 things, it probably doesn't matter, okay? But if you're talking about big vectors, then these things make a difference, okay? So, you only have 100 elements, even like 500 elements, it probably makes minuscule difference. And sometimes this is the only solution because the length of what you're doing is unknown, right? If you don't know how long it is from the beginning, then we don't do that. Okay, while loops. It's going to evaluate as long as the condition is true, and then it stops when the condition becomes false. So here we're going to say while I is less than or equal to 10, evaluate this. So what is the value of I when the code finishes? It starts off at 1, stores in results 1, it's going to do 1 squared, and then it iterates to 2. Okay, and then it says, is 2 less than 10? Yep, that's true. And we store 4 into position 2. It iterates to 3. So what is the value of I when it's all done? Okay, when we check, the value is 11. And so at 11, so it does 10. It stores 100 into position 10. It iterates I to 11, and then it goes back to the top. 11 less than or equal to 10, that's false. So it kicks out and it stops the loop. And so I takes on the value 11. That's the while loop. Same idea is the break. Okay, so repeat just keeps going forever until break is executed. And so here I put break inside an if statement. So it's just going to keep repeating this. And then when I is greater than 10, it's going to kick out. So in this case, it just keeps repeating. And then finally, when we hit break, it kicks out. So, so we have that. Okay. And again, I is going to be 11, and that's when it kicks out. We have keywords, break and next. So break stops the loop. Okay. And if you got nested loops, it just stops the innermost loop. And next skips to the next iteration. So what's going to happen here? I'm going to start off for I in 1 through 10. If I is divisible by 2, that is, if I mod 2 equals 0, if I is divisible by 2, then break. Okay. And if we don't do that, then we execute this line, cat I. So we're going to run 1. 1 is not divisible by 2, so we don't evaluate the break. We do 1. And then it goes to the next thing, 2. I is now 2. We evaluate this. This is true. It hits breaks and it quits. Okay. Question, if repeat needs a condition to break out, why don't we just use while? Yeah. Basically, the while loop with a condition and the repeat loop with a break, pretty much with an if statement, pretty much the same thing. It's just multiple ways to do the same thing. Okay. It's just another tool that you have if you want to use it. All right. So here we've got this. So this is going to stop right after 1. Okay. So it does 1 and then it goes on to 2. And at 2, it hits the break and it quits the loop. Whereas if I do the exact same code, except I replace the word break with next, what's it going to do? When it hits the 2, it's not going to quit. It's going to just say, oh, next, and we go to the next iteration, which is going to be 3. And at 3, it's going to print out 3. And then it goes to 4. It hits, this evaluates true, it hits next. So it skips 4. It doesn't print out this. Okay. So here, when you do this, now you get the odd numbers printed out. Because every time there's an even number, it hits the next before it hits the cat. Okay, cat would output that value I to the screen. And basically, every time we're getting an even number, it's going to hit next instead. Okay. Sequence length and sequence along basically allows us to create vectors, integer vectors. And, you know, in these things, I've been doing things like for I in 1 through 10. It's better to do something like sequence along or sequence length, because these handle length zeros better. So it's tempting to just do 1 colon length L. 1 colon length L. If L is length 3, then you know this will be 1 through 3, and you get 1, 2, 3. Sequence along L gives us 1, 2, 3. Sequence length of length L also gives us 1, 2, 3. So it feels like all of these things do the same thing because L has a length of 3. But if you have a list of length 0 or something of length 0, if you do this 1 colon length of L, now you're going to get 1, 0. And this is going to result in problems. Because here, if I say, hey, run this loop for X in 1 through length L, this would work if L was like a length of 3, right? 1, 2, 3, you know, do this. But here, we're going to say, do it for 1 through 0. And we run into an error. It says subscript out of bounds. because we're trying to subset something that doesn't exist because our list is of length 0. Does that kind of make sense? That because this is a length of 0, we're running into problems. So this is, I think a lot of people do this, 1 through length L, and it's a shortcut and it works and it makes sense, except it breaks when you have length 0. So a safer method is to do sequence along. And so if you do sequence along and you give it a list of length 0, then it gives back an integer vector of length 0, and then there's nothing that happens. Because when you try to run the loop, nothing happens. It says for x and integer length 0, well, nothing, okay? So this would be the safer method, rather than doing 1 colon length L. 1 colon length L is a shorthand, and it works in 99.9% of cases, but sometimes you get a length 0 vector, and then your code breaks, and then you need to figure out what's going on. All right, vectorizing your code. Vectorizing is a great thing, but you know, don't be overeager. If you can do it, do it. But again, don't be overeager. Let me go ahead and give you your last view quiz answer before we run out of time. Today's last view quiz answer is B. B as in bear. B as in bear. Okay. So let's say we have this function. It's a piecewise function. For x less than or equal to 0, it's negative x cubed. For x between 0 and 1, it's x squared. And for x greater than 1, it's going to be the square root of x. Okay, it's a piecewise function, and you got these, different things going on. All right. Here's a function, and it works, but it's not vectorized. Okay, so we say function f, if x is less than or equal to 0, the value is negative x, negative x cubed. If x is less than or equal to 1, else if, so that means it has to be great, if this is false, it has to be greater than 0. But if it's less than 1, then it's going to be x squared. And otherwise, which means it has to be greater than 1, square root of x. So this is exactly the function that we need. And here I wrote return value. It's not necessary to write return. Technically not the best style, but whatever. Okay. That's good, right? And notice I didn't have to write an and statement of is x greater than 0, because obviously if this is false, then it has to be greater than 0. Okay, so if I wanted to say graph this from say -2 to +2, and I run it through this function, and I say, all right, let's do x is going to go from -2 to 2 steps by 1, and we're going to plot the values. And we apply f to x, and I say x and plot values x. What happens? This is not the function I want, right? This is just negative x cubed for everything, right? It's supposed to be square root of x over here, and I'm obviously not getting that, okay? Well, what's going on is that no matter what the value is, even for this vector, where when I'm reaching 2, +2, what it's doing is it's evaluating the very first element, the negative x, okay, the -2, and this gets evaluated, and only it returns this value here. Okay, it only looks at the first value, so we run into problems. Okay, so one way to do this is I can create a for loop, and I can say, and I know I'm going over my time here. The for loop is going to do each value individually and go through this, and we get the results that we want. Okay. Another way, though, is we can write an if-else. Use if-else. If-else is going to be vectorized. Okay. If-else is vectorized, and so we can check if x is less than 0, then return this, which is going to be true. Okay. If not, then do something else. And here I'm going to nest another if-else. Okay. And so I got if-else If it's not, and it's less than this, then do this. And if that's not the case, then this square root of x, okay? And it's a lot more compact here. And if I evaluate it, then it works, okay? It gives me this warning. It says square root x, and nan's produced, okay? The reason for this, and I got the explanation here and you can read through it, but basically it evaluates all of these things for all of the values. And in some of the cases, it produces nans. Okay. I'm out of time, so please just review these last few slides. I hope they are self-explanatory and they make enough sense for you to make sense of them. Okay, so we'll end here for today, and yeah, please take the time to review the last few slides from today's lecture. All right, have a good day. We will see you guys on Wednesday, and that will be it. All right, see you guys.